Now let's consider the matrix 3, negative 2, 2, 7. We're going to use this as a basis for our system y prime equals ay. Again, assuming y equals e to the lambda t, x1, x2 gives us this equation with the determinant of this matrix, and I haven't written the matrix out, just reminding us that the determinant of this matrix has to be 0. This gives us three equations in the unknowns, lambda, x1, and x2. The determinant of this matrix is easily found. If we multiply these out, what do we get? Lambda squared minus 10 lambda plus 21. Negative 2 times 2 is negative 4. The negative of that is plus 4. 21 and 4 is 25. We get this characteristic equation, which we solve for lambda. In this case, we can easily factor the equation and see that we get the repeated solution. Lambda 1 equals 5, lambda 2 equals 5. Had we used the quadratic formula and plugged these numbers into the quadratic formula, we would have obtained 5 plus or minus the square root of 0. The discriminant is 0 here. That would have given us, again, a repeated solution. So we have a repeated solution to the equation. It's no problem to use lambda 1 equals 5. If we plug that in, we get negative 2 here and we get 2 here, giving us this matrix. Multiplying this matrix by x1, x2, setting that equal to the 0 matrix, we conclude that x1 equals negative x2, giving us the eigenpair 5 and 1, negative 1, corresponding to solution that we'll call y1 equals e to the 5t times the 1, negative 1. So that's all as straightforward as anything, and I went through that very quickly, but that should be very straightforward by the time you're looking at this particular clip. Now the question arises, what do we do about lambda 2, which is also equal to 5? We could do the same thing, but we would end up with maybe not the same eigenvector, but it would be a multiple of this eigenvector. If we plug 5 in here, x2 is going to have to equal negative x1, and we're still going to get the e to the 5t. So if we didn't get the same solution, we would get a multiple of this solution, which wouldn't be linearly independent of anything. Well, it wouldn't be linearly independent of this solution. So what do we do? Recall that in the case of linear function of a single linear equation in a single linear function, we multiplied our solution by t and got a new solution. Now that was motivated by what happens if we assume that we have a solution y2 that's some function multiple of y1, and we concluded that the function to multiply by would be t. That doesn't quite work in this case, but at least that can motivate the nature of the trial solution that we are going to use that will give us a good result. So the question becomes, what do we try?